Okay, good evening students. Welcome back in our live session. This is our evening session of new chapter. I hope you had already gone through the previous live session and previous videos. So as you can see, the title is Motion in Two Dimension, and today we are going to start our new chapter. Okay, so if you are online, there are some students, then you can write down in the comment box so I can start. Just wait for a few minutes, then we will start. Okay. Okay, so we are going to start. So first, I would like to say that I had already given you a quiz on Google Classroom, which I hope you had already submitted. And then now we are moving ahead on our new topics, that is motion in two dimensions. So as we had already discussed in earlier classes that the physical quantities can be divided into two categories. One is vector and other is scalar. Vector quantities are those quantities who need to represent the magnitude as well as direction, and they have to follow some vector laws. And scalar quantities are those quantities which had need to represent only by magnitude and unit, and there is no need to say any type of direction. So it is already clear to you. Okay, so now I had already make a small video on vector analysis, that how the vectors are represented. You can access that link from the description of this video. Now we are moving to this PDF. As you see that scalar and vectors, motion in two dimension. So some quantities can be described by a single number, for example mass, time, distance, speed. One piece of information is enough to describe them fully, that is called scalar quantities. But on the other hand, some of the quantities are need to explain the single number as well as with the direction. Those quantities are called vector quantities, and that can be represented by this method AB, and by showing the arrow on above of that. So let's discuss on first unit vectors. Unit vectors. How we can represent a unit vector? First we should introduce that. For that we can go to this format. Okay, so suppose ये हमारे पास एक Cartesian system आपको दिख रहा होगा. Suppose this is a x-axis. This is x-axis and this is your y-axis here. And this is a point P whose have the coordinate x comma y. As we know that if there is a point P, तो हम इस point का projection x axis पर डाल देते हैं और इधर इसी point का projection y axis पे डाल देते हैं, तो हमें इसके coordinate पता चल जाएंगे x comma y. So vector OP means the position of this point P from the origin. So here the vector OP, this is the method of representation any vector. This is the method of representation. So here the vector is OP is actually representing the position vector. This is called position vector. To you, this is x-axis, and on above the plane, there is an z-axis perpendicular to x and y shown to you. So this is your y-axis, okay? This one is x-axis, and this one is z-axis. Okay? Okay. Now, suppose you can see that in x-axis there is a 1 square is here, then 2 third, second square, there is a third square, fourth square, fifth square, and 6th, 7th, 8th, and as here in y-axis also first square, second square, third, fourth, fifth. Basically, all the axes are divided in certain steps, certain units. And suppose this x is representing some kind of force, and I say that one square equals to 2 Newton, and suppose you are here and this is your position. So how much force you had applied till now? So that is 2 plus 2 plus 2. that is 6 Newton. So this is the position of 6 Newton force. Now you are here. So again 6 is here. So plus 2 8, plus 2 10, and plus 2 12. So this position is representing 12 Newton force. So as you can see, this 1 2 3 4 5 6, these are the magnitude, while 1 square value, that is 2 Newton, is the unit value of the square. So this is our unit concept. So similarly, in any axis, just like this 6 2 times 12, just like this, suppose there is a point, P whose coordinates are x, y, z, and the unit vector in x-axis is I cap, unit vector along y-axis is j cap, and unit vector along x-axis is k cap. In that condition, position vector OP can be written as OP equals to XI plus YJ plus ZK. So this is the method of Cartesian representation of any vector. इसके अलावा, other than this, I had already told you in the previous video of vector, that length of the vector is actually represents its magnitude, and its arrow, its head is representing the direction of the vector. Now moving ahead, let's discuss some more examples of vectors. Okay, so let's discuss some more example of vectors. Suppose there are two vectors having equal length in opposite directions. Suppose there is a vector, this is a vector, and this vector. These two vectors are having same direction and same length. So basically these are equal vectors. Okay, because the direction is same and length is same. So this type of vector is called equal vectors. Equal vectors. Okay. Now, suppose there is another pair of two vectors having same length but opposite in direction. So such type of vectors are called opposite vectors. Opposite. Equal but opposite vectors. या reciprocal vectors भी कहते हैं. Opposite vectors. Now, in both the cases, this pair is called parallel vector also, and this pair is called anti-parallel also. Now, this vector, this pair of vector, as you can see, in this pair, vector length is different. This vector is little bit have much length compared to this one. So, these two vectors may be parallel, but of course they are not equal vector. तो ये vectors जो हैं वो केवल parallel vectors की condition में आएंगे, equal vectors इनको हम नहीं कह सकते. On the other hand, similarly, these two vectors are still unequal but anti-parallel. So I hope these four conditions you had familiarized, that what is the basic difference between equal, opposite, parallel and anti-parallel vectors. Now Let's understood some more examples of vectors. So basically unit vector is the vector whose magnitude is 1. Suppose there is a vector I cap, which is the unit vector in x-axis. Its magnitude value is 1, and that's why it is called unit vector. Similarly, j cap is also a unit vector along the direction of y-axis, whose magnitude is also 1. K cap, it is also a unit vector along z-axis, whose magnitude is 1. So any vector whose magnitude is unity is called unit vector. Now, there are some more examples of vectors. Suppose there are two vectors a, b. One is, this vector is a, suppose this vector is a, and this vector is b. So as you can see, the direction is not same, even the length is not same, they are not parallel, but they are not exactly anti-parallel. So these are called basically different vectors. ये एक दूसरे से बिल्कुल अलग है. So these are called individual valued vectors, and these vectors can be added or subtracted easily. Okay, so later on in the Okay, so as you can see in this diagram, there is a unit vector representing in x direction I cap, in y direction j cap, and in z direction k cap. Okay. Okay, so let's move on. Addition of vectors, vector addition. Now we have to add two vectors. So basically for adding two vectors, what we do actually we connect the tail of the one vector to the head of the another one, and then we take the resultant. So this is the little bit a simplified manner to add two vectors dramatically. Okay, if we are representing the vectors diagrammatically, then we have to add in diagrams in a line format. So that's we are going to do right now. So suppose there are two vectors. One is a, vector a, and this one is vector b. This one is vector b. Okay, and now what we do, we have to do actually vector a plus b, vector a plus vector b. So what we do, we draw the vector b to the head of vector a, and that's how we can add the vectors. So for that we can move this vector to this point here. Okay, so now this vector b here, your vector b is here, and then we can join this whole line. So this is called, this longest length is called vector c, which is equals to a plus b. Okay, vector a plus b. Now you can easily see that the length of vector c is greater than a and b, because c is the resultant of ab. C comes with the addition of two vectors, so obviously the length of vector c must be greater than a also, and it must be greater than b also, and that's why the addition is all about. Now suppose we have to do the subtraction of these two vectors, then how we can do that? Let's move on. Suppose we have to do a minus b. So in the same diagram, what we can do, suppose we have to determine A vector minus B. So in vector, the negative means the reciprocal of the vector. So what we do actually, we just reciprocate the value of vector B, and then easily we can find the solution. Okay, so as you can see, we use the same direction. A is here. We use this vector A. So this is vector A. As you see, we are not changing the slope of vector. We are not changing the length of the vector. We are using the same vector. So there is vector A, and now we are reciprocating the distance. So now this is our vector B here. There is head. So as you can see, previous vector B and new vector B is basically, it is the reciprocal of positive B vector. So now by joining these two lines, we can get our vector D, which is equals to A minus B. Now if you observe these two diagrams, the previous diagram and this diagram, then you can easily observe that vector C is quite greater than vector D. And why it is greater? Because C is representing the addition and vector D is representing the subtraction of two vectors. So by these methods we use to add and subtract the two vectors. I hope you can get this particular idea that how we can do that. So this is the method of diagram. This is a diagram method. But now suppose we get some particular value of numerical value of vector in numeric forms, then how we can get the solution? Okay. Students, if you have any type of query, then you can write down in the comment section. I'll try to sort out those queries. Okay. Now suppose there is two vectors 2i plus 3j minus 4k. This is suppose vector A. This is vector A, and suppose another vector is 3i plus 5j plus 8k. And this is your vector B. Your vector B. Okay. Let's change little bit the, okay, that's maybe. Okay, so these are two vectors here. So in previous part we had add two vectors and subtract two vectors by using the diagram method, and now we are using the numeric process of addition and subtraction of two vectors. Suppose there is a two vectors given to you. As you can see, the little bit complicated to make the arrows on that, so let's make the arrow. Okay, and there is a cap also here. Okay, there is a cap also here. You see, cap is the representation of unit vector. Okay, when you apply the cap on any variable or any vector variable, then it makes him or it as a unit vector quantity. So now, as you can see, suppose you have to get the value of vector c. So vector c is representing the a plus b, vector a plus vector b. So we use the normal simplified method. There is no need to complicate it. Just write 2i plus 3j plus minus 4k. You can write all the vectors, and then plus vector b. So you can add I component to I1, that is 5i. So the resultant will be 5i cap plus 3 plus 5, that is 8j cap. And now, as you can see, minus 4k plus 8k, so it is plus 4k. So this is the basic simple method to add two vectors. Now, how we can get its magnitude? So for magnitude, if there is a vector is xi plus yj plus zk is here, is zk is given to you, and it is asked to you to calculate its magnitude, then the magnitude of this vector, suppose this is a vector p, so magnitude is p, vector p, magnitude of vector p. Magnitude means numerical value. Okay, that is 2, 4, 5, 6, यानी उसकी numerical value कितनी है, that is called magnitude. So the magnitude can be get by under root and the addition of all the components of the square of the unit vectors, that is x square plus y square plus z square. Okay, so as here, so for getting the magnitude of vector c, for getting the magnitude, we can under root 5 square, that is 25, plus 8 means 64, plus 4, that is 16. Okay, so now what you do, you have to do just, you can just add all these terms, that is 25 plus 64 plus 64 plus 16, that is become 105, and just take the root of this value. So under root of 105, and it becomes 10.2, almost 10.2 unit. 10.2 unit is the numerical value of this vector, 10.2. Now, if it is a vector, then how we can get its direction? So as you know that unit vectors are the best way to get the direction of any vector. अगर हमें किसी भी वेक्टर का यूनिट वेक्टर पता है, यूनिट वेक्टर की वैल्यू पता है, तो हम उसकी डायरेक्शन भी निकाल सकते हैं. So as you see that any vector is the combination of two things, that is its magnitude value and its direction, that is its unit vector c cap. So as you know, if you get the you want to calculate c cap, then c cap is equals to vector c upon magnitude of c. So that is vector direction of vector c, that is a plus b, that is c cap is vector c. The value of vector c is here, that is 5i plus 8j plus 4k, and just divide this whole vector with its magnitude value, that is root 105 or 10.105. Okay, so this is the method of addition of two vectors, or how to calculate the magnitude or its unit vector. So and it is simple of the subtraction also. If you want to subtract a minus b, if you want to calculate the a minus b, then just put the bracket here, 2i plus 3j minus 4k, subtraction, sign of subtraction, that is minus 3i plus 5j plus 8k. So automatically all the signs of vector v will be reciprocated. So the 3i of positive become negative 3i, positive 5j becomes negative 5j, and positive 8k becomes negative 8k, and easily you can calculate the subtraction, and by the same process you can get the vector magnitude and unit vector. So I hope this live session could be useful to you. Now we are concluding this live session here. In next session we will perform some numericals related to vector additions, some examples of vector addition and vector subtraction, and yes, there is a still very important laws of vector addition is here, that is triangle law of vector addition, parallelogram law of vector addition, and in next few sessions we will go through those laws. Till then you can watch this live session again and again. It is always on my channel. You can go through the previous videos also. Till then, thank you learners. Kindly like, share